All right, welcome back. So we are going to figure out now how to check for the win condition. So we've set up the ability to actually put X's and O's on the board. One bug that we have, real fast before we get too far into this, we're going to go ahead and fix this bug. One bug is that we can go in and change what's on the board. And so we're not actually checking to make sure that that value is not filled before we can click. So that'll be a really easy fix. What we need to do is we need to go into this box level component, and for this on click, we just need to put a condition in here. And so we're going to say, so we've got the value, and so we're going to say if value, if not value, then do the on click. And so an empty string is falsy, meaning that it is not exactly equal false, but it is falsy. So like the number 0 and an empty string, things like that are falsy. And so this will evaluate to true if the string is an empty string, right? And so now this should be fixed. And so this part still works, and nothing happens when I click this, right? So so that's good. So I'm clicking, nothing's happening. Cool. So we've got that fixed now. All right, cool. So then let's move on to actually checking for the winning condition. So in our render, sorry, not in our render, in our handle click, before we actually set the state, we're gonna check for the win at that time. Okay, so the first thing we're going to do is we need to take our new grid and map it and filter it. And so I'll kind of show you what I mean by that. And so we're just going to say we'll call this grid items, and then we're going to just call it, we'll make a function called map grid indexes, and then we'll figure out in a minute what it's going to take. All right, cool. So we're going to make a function called map grid indexes, and what that's going to do is that's going to essentially take our grid of our 3x3 grid, our array of nested arrays, and give us values that we need to evaluate whether or not this is a winning condition. So this is going to be a function that can stand alone, so it does not need to belong to the class. And so it was called map grid indexes, and we're going to say that it's going to take in a grid, and we're going to check it against the value, because we can also filter it by that value. So all right, here we go. So we need to get the we need to map over the grid first, and so we'll call this mapped items. So we'll say const mapped items equals grid dot map, and so the first thing we're mapping over is each row, and so we're going to map over the row. We're going to go ahead and grab the index of the row as well. All right, so we have that, and then each of these rows, remember, is an array, right? So we're going to map over that as well. So we're going to say return row.map, and now this is the column, and we have the column index available to us. And then what we want to return is the row index and the column index. And then we can, what we can also do is we can give it the value as well. We go and pass the value to it. Actually, no, we're not going to do that yet. We're not going to do the filter just yet. Right now, all we're going to do is map over these. And so let's just see what that gives us whenever we call that function. So mapped items, we need to actually pass in these items right now though. So the grid and the value, although we're not using value yet. So we need to pass in grid and value right here. And so grid, we're going to make that our cloned grid. And then for value, we can just pass in our current value. The value that either the X or the O, whichever one we're currently on. And so right now that's not going to do anything because we're not returning anything. Right now we're just going to run this function. So let's see what we get. So there are my mapped items. Okay, so right now we're still getting the 3x3 grid, but you can see we're getting column index and row index. We're getting an array of objects. So now all we need to do is flatten that as well as filter it. Okay, so we have this mapped items. We're going to make a new function and we're going to call it something like flatten and filter arrays. All right, so we're going to say up here we'll say const flatten and filter arrays, and what that's going to take in is going to take in our grid, and we're going to first just declare an empty array as an output. This might not be the absolute cleanest way to do it, but I think it's going to work. It's going to get the job done. This video, of all the videos, this is going to be kind of the gnarliest looking one as far as the code goes. It's not going to be pretty. It's maybe not going to be the cleanest at times. This is definitely one of those times where it's not going to be super clean. We can go back and clean this up here in a minute as well. All right, so now what we're going to do is we're going to loop over this grid of arrays. Remember, this is an array of arrays. And so now each of these items is an array. And then we just want to say output dot push array. Now, that right now isn't really going to do much for us. That's actually going to kind of give us the same structure. So what we can do is we can use the spread operator to spread out that array, which should then give us what we need. And so if I say return output, and then here I can say return flatten and filter arrays, and I need to pass in the grid, which is these mapped items. And then from there, now, let me call this grid items, and let's console log grid items. Let's see what we get. So grid items, look at that. Now we've got a flat array of what we need. Now, we want to filter this out as well, right? Because we only want the ones that apply to the current value that we are on. Okay, so what we can do is there are, I guess, two places we could do it. You could have just a function that does the flattening, and then you could apply the filter here, but we've named this flatten and filter, so let's just go ahead and do it that way. So what I'm going to do is I'm going to take this value that we have here, and I'm actually going to pass it in here as well, right? So now these are those named params that we talked about. And so now I've got, now that I've done that, where am I? Flatten filter arrays. Now I actually have to call this grid. I can't just call it whatever I want because now it's named. This is an object. And then value. Okay, so I've got grid and value. And so what I want to do is first, actually, I need to, you know what? This is not the way to do it. Sorry, guys. I was thinking the wrong way for just a second. So um, the value right now, all we're doing is we're just creating the new grid, um, but we're not actually taking into account the value at all whenever we build it. So then we no longer have the value in these elements up here. And so what we actually want to do is check for the value first, or apply the filtering in our return, like do some kind of conditional return. So let's first just say um, return column equals value. Now remember, this column is a string. This represents either an empty string, an X, or an O. And so what we're going to say is if, basically, if the column equals the value, then return it. So let's see what that gives us first. Before we do anything else, let's just kind of see what we get as a result. So here's our flat array. So you can see we have data and then a whole bunch of false. Same thing here. We have data here, but then a whole bunch of false. And then here, oops, here, data and a bunch of false. So because we're passing in the current value, it's only giving us the boxes that match the current value. So that's exactly what we want. So now we can filter it. So we're going to go and apply the filter here. So we're going to say return output dot filter, and then we're looping over each box, and then we're going to say filter where box is present. So this should give us what we want. I'll talk about what this syntax is in just a minute. This should give us what we want, I think. Grid items, there we go. And grid items is too long. Yeah, two has a length of 2. So that's what we're looking for right there. So let's talk about what this does. This bang bang. So you probably know that a single bang operator basically just flips the value. What we are checking for is essentially, does box exist, right? And so we could have done this. We could have said return box does not equal false, right? And that actually should work as well. Yeah, so that still works. I just think that this is just a little bit cleaner. I don't know. It's personal preference, whatever you want to do. I personally like doing it this way. All right, cool. So now we're using the value here whenever we run the map, and then we are able to filter out what we need. We're able to flatten the array and filter it all in one go. Cool. So we've got our grid items now that have been flattened. So now what we have to do is check for the winning condition. So we'll make a function called check win. All right. So we're going to say we'll make a variable called has won equals check win will be the name of the function, and we're going to need a couple of things. We're going to need, well, for sure, the grid items that we just made. That's why we have them. And then we could take a couple approaches with this. We could just always know that it's going to be traditional tic-tac-toe, and you have to get 3 across, 3 down, or three diagonal to win. But since we've been building this in a way where we can have a customizable number of rows and columns, we should also make the number of consecutive squares to win. We should make that customizable as well. All right, so I'm going to make a variable. We'll put it up here, and we're going to call it winning string. We'll call it min to win. I like that. Min to win. All right. Min to win is 3. All right. So we're going to say win string is min to win. All right. Now check win right now is not a function, of course, because we have not declared it. So let's declare a function. So check win equals, we know we're taking in grid items and our win string. All right, cool. So this is where it's going to get a little bit strange because we essentially we're going to take this flattened array of these values, and we essentially need to take that row index and that column index and see if we can build a string of consecutive boxes that and build an array with each of those and see if the length of that array is greater than or equal to our min to win value, right? And so if this is a little bit confusing right now, hopefully as I go through it'll start to make sense. The approach I'm going to take is, oh yeah, check was not a function. Let me save this. That should at least get the error to go away. Okay, so probably, hopefully, okay, that doesn't break. So yeah, so what we're going to do is think of this as like compass directions. So this is north, this is northeast, this is east, southeast. You get the idea, right? Um, although technically we're going to be sort of doing it the reverse way for the sake of the code maybe being a little bit more readable. In other words, we're going to say that ascending numbers is north, and well, ascending numbers will still be east, but we're going to say ascending numbers for like the row. As you go to a higher row, we're going to call that north, even though it's going to look like south here. So anyway, just hang in there if you don't know what I'm talking about. If you're like, Austin, what the heck are you saying? It should make a lot of sense here in just a second. So first thing we're going to do is we're going to make a variable called has1. We're going to set it to false. The reason for that is we're going to use a while loop. We're going to be doing all of these checks, and they're going to be a little bit of expensive checks, meaning we're going to be checking for all these different winning conditions, and all we care about is the first case that there's a winning condition. So for example, if we have this, oops, I just messed it up. If we have, there we go. If we have this, right, there are now 2 ways where player X won. All we care about is the first time that we found a has won. We no longer need to check for the other ways that that player has won. All right, does that make sense? So that's sort of why we're going to have this has won, so that it can help us escape from these checks. It's also we're going to be using something like a while loop instead of doing for each. Because with a for each, you can't really escape from that. But with a while loop, you can. So, we're going to have has one is false, and then we're going to declare an iterator, setting it at 0. So we're going to say while I is less than. So we have our grid items, which is our flat array now, right? So this check when grid items is this array that we flattened and filtered. So if I've put 2 X's on the board, this is two items long, right? So that's all we care about. We only care about the items that are of the value we're checking, right? So while I is less than grid items dot length, and while you have not won, then do something, right? All right, cool. So here's where it's going to kind of start to get a little bit weird. The first thing we're going to do is just make sure that we increase our value of I. Otherwise, you have the potential to be in an infinite loop that will never escape. And so, anyway, so that's not good. We want to make sure that we have that in there. And then at the end, we're just going to return has one, whatever it is. So we need some way for has one to become false. And so we're going to write a function that will that returns a boolean that essentially is has one. So we're going to say has one equals and then some function. All right, cool. For now, I'm just going to hard code it to false. So has one should always be false. Has one and then has one. So now has one should always be false, no matter what. Right? Has, because I'm hard coding has one to false. So this is never escaping. All right. So now let's figure out how we're going to build this out. Okay. So inside of each of these, we have access to each box that contains our value. And so what we want to do is take that item and then also taking all of the grid items and the win string and write some function that's going to compare to see uh, if any of those possible combinations create a winning condition. All right, so we are going to take each item, compare it to the rest of the items, passing in this one string. So we'll call it compare to rest. So we're comparing it to the rest of the items. So this is a function we have not written yet, but compare to rest. As I said, we're going to pass in the current item. So that will be grid items I, meaning the current item we're on, except we're passing in an object now, so that's not going to work. Let's call this current item. All right, current item, and then we need to pass in our grid items all together, and then we need to pass in the win string. We can delete this comment now. All right, so compare to rest, we have not actually built that function yet. All right, so we have compare to rest, and we know that it is some function that will take in a current item, all of our grid items, and our win string. You might be wondering, why are you passing in the win string when you have it available to you out here? And I'll talk about that. So we have this min to win, right? And in all of these cases, we're taking this value and passing it in as a parameter when we have it available to us outside of the function. So you might be thinking, you have it available, why not just reference it outside the function? The reason is that it's good to be in a practice of writing what's called pure functions. And so a pure function is something that takes in an input, uh, basically the oversimplified, or the simplified definition of a pure function would be it's a function that if it takes in the same input every time, it will always return the same output. And so, for example, if I only had these two values that I was passing in, then what I just said would not be true, because it is dependent on something outside of itself to give you the return value. So you want to pass in all of the data that you need into the function. You don't have to, but if you want it to be a pure function, then yes, you do need to pass in all of the data that you're going to need for the function in as arguments. The reason for wanting to use pure functions is that they are really easy to test, and you can typically make them more reusable. So I could have this function live outside of this file in perhaps a some sort of utilities folder, and then pull this function in. And this function in and of itself is completely oblivious to what this value is. It does not know anything about it. All it cares about is what I give it. And so anyway, it makes it really flexible, and then more reusable. So anyway, it's a good habit to get into. All right, enough about pure functions. Let's keep moving. So this is where we're going to kind of get into the compass thing, right? And so we're going to make our 8 directions. These are going to be 8 arrays, right? So we're going to say const n for north equals an array that just starts with our current item. We're going to do 8 of these. So we're going to have northeast, and we're just going to go through all the directions. East, southeast, south, southwest, west, and northwest. That should be 8. Yep, that's 8. Okay, so that's all of our arrays. And then basically what we're going to do is we're going to take each of these arrays and if the row, if the box like right above current item is checked with the same value, then we're going to add it to north. If the box right below current item has the same value, then we're going to add it to the south array. And so this is why I was saying earlier when I was talking about like we're going to call this north and this south. I think it's going to make this craziness a little bit more readable when we're already about to kind of have some sloppy code, just a little bit. So we're going to make a function called, we'll call it apply direction, because we're going to apply this data to every direction. So it's going to take in some item, and then this is where we're going to check for all of our conditions. And so the main two things we have to do is we have to figure out the difference of the rows between two items and the difference of the columns between two items. And so all we care about whenever we're doing this, all we care about is the last item in the array that we're on, right? And so I'm going to make a function called diff rows and diff columns. So we'll say diff columns. It takes in an item in an array. We'll go ahead and do it that way. And I like to put space on either side. I also like to alphabetize these, actually. Usually. Alright, cool. And so we're going to say last item equals array with the index of array.length minus 1. So this is kind of just a normal way of saying give me the last item in the array, right? So if an array is 9 long, then the length is 9, subtract 1 is 8, index 8 is the last index of an array that's 9 long, right? So now we've got the last item, and then what we want to do, we know that every item is going to have a call index, right? And so we're going to say return item dot call index minus last item dot call index. Okay, so that's going to give us the difference between the columns for the last item in the array as well as our current item. This is going to make more sense soon, I promise. Then we're going to say diff rows. We're going to essentially do the same thing. So we're going to say item last item. This is the same idea. Array.length minus 1. And then we're going to say return item dot row index minus last item dot row index. Okay. So now in this apply direction, we are passing in an array and we're passing in our current item. And so we're essentially going to have a really big if-else-if statement. Okay. So this is where it's going to get a little bit weird. So we're going to say if diff rows, and we need to pass in an array. So the first array we're going to check is our north array, and then passing in the item, right? So we have diff rows, passing that in. So if diff rows for that equals, so we're checking for north, so we're going to say 1, right? Because basically we're saying if we go up a row. Because what this function is doing is taking in the array, it's taking in our current item, and then we haven't actually called this function yet, but it's taking in our current item and basically saying, okay, is this item one row above it? If so, I want to push to that array. I want to push that item to the array. Now, this is not enough information. This just tells us that it's up, but it doesn't tell us that it's straight up. And so that diff calls function will help us know if it is straight up. So we're going to say and diff columns, and then the north array, as well as the item. And if that equals 0, then it's straight up. Okay, so then, like I said, this is like a big if else if, because if one of these is true, we don't need to run the other one, right? So usually I don't like to copy and paste, but I'm going to go ahead and copy and paste in these cases just to save time for this video. Let me just go ahead and get a few of these in here, and then we'll kind of move forward from there. So let's see, that's 1, 2, 3, 4, maybe 4 more. 1 for each direction. 5, 6, 7, and 8. I could do the whole just like copy paste thing, but that starts to get a little bit weird whenever you're doing that with like if else statements. So it's really easy to like spend more time trying to make sure that you've got the right number of brackets on the page than it is to just do it the way I just did it. All right, cool. So now we're going to check for northeast. So for northeast, we want diff rows to be 1, but we want diff columns. If we're going east, we want that to be 1 as well. And if this is true, we say northeast.push the item. Now we're going to check for east. So for east, we want it to go straight across. So we want the difference of the rows to be 0, the difference of the columns to be 1. And if that's true, then push the item to the E array. Now we're checking southeast and southeast. So if the difference of the rows, if we're going south, that would be -1, but then difference of columns will still be 1. Southeast.push item. Now we're checking south, -1, and south, 0. If that's true, then push to the south array. Now southwest, so this still has south in it, so we're checking for -1. And then southwest and -1. If that's true, push the item. Now for west, since it's straight west, north and south is 0, and this would be -1. Push this item to the west array. Else, if it is northwest, we want this to be 1, and we want this to be -1. If that is true, then for northwest, push the item. All right, cool. So we have this apply direction function written. And so we're not actually using it yet, but we're close. We're close to being done with our logic. So the next thing we're going to do, because basically what we have to do is we have to pass in all of these different items and apply it to all of these different directions to see if we can build an array that's 3 long, or whatever our when string is, right? So now what we're going to do is inside of here, actually, While we're still in inside of this function, we can loop over all of our arrays and just go ahead and um, look for any arrays that possibly could be meeting that win string length, right? So let's just make an array of all of these arrays, so it's a little bit easier to loop over. I'm going to say north, northeast, east, southeast, south, southwest, west, and northwest. All right, cool. That will be called arrays, not array. Okay, cool. So now we're going to look for the winning arrays. So we're going to say const winning arrays equals arrays.filter. So we're going to loop over each of these arrays, and we're going to return the ones whose length is greater than or equal to this win string that we've passed in as an argument. And then all we care about is, are there winning arrays, right? We already know that we're only dealing with like either just the x value or just the o value. So all we care about is, did we find some, right? And so we can say return winning arrays dot length is greater than 0, right? So this will equate to a boolean, to either true or false. It says win string. That's not right. Win string. So this is a boolean, right? This will either be true or false. And so now this whole apply direction function actually is kind of like our final step in checking to see um, if the winning condition has been met. All right. So now we're going to take a similar approach here as what we did down here with this, like using a while loop. We're essentially going to do another while loop. And so we're going to say let has1 equals false. It's okay to do this because each of these is scoped inside of its own function, so there's no conflict of naming variables this way or worried about overriding them. So same thing here. We're setting I to 0. Not a big deal because this is only available inside of this function. All right, cool. So now that's another reason to write pure functions is it makes it a little bit easier to not have to worry about like just like variable scoping and that kind of things. All right. So let's say while I is less than grid items.length and has not 1. So it's the exact same condition. Like I said, it's really, really similar. And not has 1. Now what we want to do is set has1 equal to this apply direction. And we're going to pass in the current grid item. And of course, remember to increment your I. And then, just like before, return has1. Okay, so let's talk about what this is doing. Let's walk through all of this. I know that's a lot to take in. So the first thing we did was we mapped over our grid and we flattened and filtered it so that basically we would just get a really flat array of only the value that we care about, but we built an array of row index and column index so that we had that data available to us. And then now what we're doing, this check when function, we are iterating over this flat array and we are going over each item and comparing it against that whole array to see if we can build an array that matches the length of the win string. Is that length or more? So what this function does, again, this is just the really brief one. We initiate an array for all 8 directions, giving it the current item that we're on as the first item that we want to build off of. And then we loop over all of the grid items and we check to see if we can build off of these arrays, right? So this apply direction, we're saying, okay, let's look at the first item in the array. Is it right above the current box that we're on? If yes, add it to the north array. If it's not, then is it right above and to the right of the box that we're on? If it is, push it to the northeast array. Else, if it is just to the right of the current box that we're on, push it to the east array. If it is, you get the idea, right? So this is why it's this else if, is because it's never going to be both right above and right below, right? So only one of these would ever be met anyway. And so as soon as one is true, we don't need to check these others, right? Because again, we're trying to, this is already an expensive equation. So we're trying to just find every opportunity to eliminate expense. All right, cool. So now, I think this should actually give us our value. Let's see. So we're going to console log has one now. And so has one is false, which is what we would expect. Has one is false. And has one is true. Cool. So now, just for fun, let's set min to win to 2 to see if has one will be true after just 2 consecutive ones. There it is, has one is true. And if I go diagonal, has one is true. And if I go vertical, has one is true. Just to see, let's go a 6x6 grid, and you only need 4 to win. Let's see. So has one is false for all of these. Now has one should be true, and it is. And if I go diagonal, oops, messed that one up. And now has one should be true right there, and it is. So we can see that it's working as intended, and that's why I wanted to kind of take this approach. You could very easily not make it so customizable and just have, like, you could go ahead and build out all the winning conditions and then just check to see if those are met. Like if this were your normal 3x3 grid, oops, your normal 3x3 grid, you could basically build out this array. Like there are only whatever it is, 7, 8 winning conditions. So you could go ahead and just make an array of all 8 winning conditions. That totally works. But I like the idea of making it a little bit more customizable. So in the next video, we are going to figure out now how to disable the ability to continue the game, because right now, once you win, um, you can still keep playing the game, right? You're not supposed to be able to do that. So you've got to be able to stop the game and then also provide some sort of feedback to the player that they have won the game.